Okay. Seems like everything we do frontwards and backwards in math. Well, remember, if we had x squared equals 16, how would we solve for x here? How do we undo something squared? Square root. Therefore, x would equal plus or minus 4. Now, what if it's backwards? What if we have the square root of x equals 5? Now, how do we get rid of the radical? We square it. And whatever you do to one side, you have to do to the other side. So this is x equals 25. Okay? And if we have this, if we have the square root of 3x equals 6, again, how do we get rid of the radical? We square it. Remember, whenever you multiply the same number times itself, the radical just goes away. So this is 3x equals 36. Right? 6 squared, 36. Divide everything by 3. X is 12. Okay. And the same thing here. If we have the square root of 3x plus 4 equals 8. How do we get rid of the radical? We square it. Whatever you do to one side, you have to do the other. So now we get, once you square it, you get 3x plus 4 equals 64. Subtract 4 from each side and have a real simple algebra problem. 3x equals 60 divided by 3, x equals 20. So now what we do here, once you get to this part right here, we didn't do it in the other ones, but what you have to do here is you have to plug this back into the original equation. The square root of 3 times 20, okay, x is 20, plus 4, does that equal 60? Well, does that equal 8? Square this side, square this side, so we get 3 times 20 is 60. Oh, well, again, the square means the radical just goes away. So we have 3 times 20 plus 4. Does that equal 64? 3 times 20 is 60. 60 plus 4 is 64. Does equal 64. So this is a good solution. And what if we have this? 5x minus 1 square root of that plus 3 equals 0. Okay, so we subtract 3 from each side, and we
Can you move your paper up, please?
Sorry. How's that?
Yeah.
Okay. Now we subtract 3 from each side, and we get the square root of 5x minus 1 equals negative 3. And how do we get rid of the radical? We square it. I'm going to square that side also. And when you square this, the radical just goes away. So we have 5x minus 1 equals negative 3 times negative 3 is a positive 9. Add 1 to each side. 5x equals 10. Divide by 5. X is 2. Right? Right. Now we have to plug this back into the original equation. The original equation was this one. Square root of 5x minus 1 plus 3 equals 0. Now again, we have x is 2, so we plug it back into here. So we have 5 times 2 minus 1 square root. Let's subtract 3 from each side equals negative 3. Right? Right. Mm-hmm. And then to get rid of this, we square it. So we have 5 times 2 minus 1. Does that equal 9? 5 times 2 is 10. Minus 1 is 9, so that works. Mm-hmm. Everybody got it? Okay. Okay. Mm-hmm. Okay, before I forget, we're going to start the review of we'll start the final exam review Wednesday. I don't have the real test in, but I do have last semester's. Everybody have this? Okay. Mm-hmm. Now, what if we have this? Square root of 4 minus x. Square root of 4 minus x equals x plus 2. Okay, again, we need to get rid of the radical, so we square it, and we square this. This one, the radical just goes away, so we have 4 minus x equals, okay, x plus 2 times itself is equal to x times x squared plus 2x plus 2x plus 4. So we get x squared plus 4x plus 4. Okay? Now we're going to add x to each side. And we get, actually we're going to subtract 4 and add x to each side. Subtract 4, add x to each side. Now what we're trying to do here is we're going to set this equal to 0. X squared plus 5x. 4 minus 4 is 0. Right. So now we factor this. We're going to get x open x plus 5 equals 0. Now remember, we take each one of the factors, excuse me, each one of the factors and set them equal to 0. So x is going to equal 0 and x plus 5 equals 0. Subtract 5 from each side. X equals negative 5. Okay, now we have to plug them back into the original equation. Wherever there's a, the original equation was the square root of 4 minus x. Does that equal x plus 2. That was this, before we squared them both. Now we plug 0 in for x. So the square root of 4 minus 0, does that equal 0? Okay, we're plugging 0 in wherever there's an x. 0 plus 2. So we have the square root of 4. Does that equal 2? Yes, 2 equals 2. So 0 is a good solution. Now what about negative 5? Same thing. We have the square root of 4 minus a minus 5. Does that equal negative 5 plus 2? Okay, we plug negative 5 in wherever there's an x. A 4 minus a minus, or the opposite of negative 5 is a positive 5. So that's going to be the square root of 9. Okay, 4 plus 9, or plus 5 is 9. Does that equal negative 3? Negative 5 plus 2 is negative 3. Square root of 9 is 3. Does not equal negative 3. So this, where x is 5, this is not a good solution. Or sometimes they use the term extraneous solution. A-N-E-O-U-S. Extraneous solution. Okay. Okay. Everybody have this? Where is everybody? Well, Miss Mabry's here, so that's all we need. And Miss Ayoa. And Miss Richard. Okay, these are called complex numbers. C-O-M-P-L-E-X. Complex numbers. Okay, we have what's called an imaginary unit. You remember we talked about the square root of 9, or the square root of negative 9. Can we take the square root of negative 9? Is there anything times itself that will be a negative number? No. Up until now, this was undefined. But now we have, I told you back a couple of weeks ago that we have a way of dealing with this. They're called imaginary numbers. The imaginary unit is lowercase I, cursive kind of, equals the square root of negative 1. Okay, I equals negative. Now if we square both sides of these, then we say therefore I squared equals, square both sides, I squared equals negative 1. You are going to get one of these on the final exam, or there has been in years past anyway. But I think you're only going to get one, maybe two. Oh, that's good. So what if we have this? The square root of negative 16. Now, before we said the square root of a negative number was undefined. But we have to have a way of dealing with this. Now remember, I is the square root of negative 1. So what we can do is, this is going to equal the square root of -1 times 16. Now we know that the square root of -1, now we can break this up into the square root of -1 times the square root of 16. And what is the square root of -1? I. What is the square root of 16? 4. What have I gotten on my hand? Okay, you can do it like this, or you can do it like, if you have a negative inside of the radical, just bring an I outside. Okay, it's basically the same thing. I just broke it down like that to show you what is the story. So again, if we have the square root of -25, that equals the square root of -1 times the square root of 25. The square root of -1 is I, and the square root of 25, of course, is 5. Mm-hmm. Mm-hmm. Okay, and what about this? What if we have the square root of -4 times the square root of -25? Now the square root of -4 is 2i, right? Right. Times, remember, the square root of -1 is I. Now the square root of -25 is 5i. So this equals 2 times 5, which is 10. Now I times I is I squared. And remember, I squared is -1. So this equals 10 times -1, which is -10. Mm-hmm. Okay, we're going to use this thing more and more, where you have I times I is I squared, and I squared is -1. You might want to write that down somewhere, these things up here. You might want to write those down. Mm-hmm. Okay, and if we have square root of -3 times the square root of -7, this equals I times the square root of 3, okay? Remember, when you bring the negative out, it's just an I times, and again, the square root of -1 is I times the square root of 7. Now, we're going to multiply these. I times I is I squared, and we know what the value of I squared is -1. And then square root 3 times square root 7 is square root 21. Can we factor 21 into something that's a perfect square? No. But we do know what I squared is. I squared is -1 square root 21. Mm-hmm. Mm-hmm. Everybody got this? Here we go. Okay. How about this one? square root of -2 times the square root of -8. Okay, this is I times the square root of 2 times I times the square root of 8. Now we multiply these. I times I squared, and remember we know what the value of I squared is, it's -1 times the square root of 16. I squared is -1, square root of 16 is 4. So our answer here is -4. Okay. I don't deserve a good cough drop. Everybody got it? This is really some good fun, huh? Miss Ayola, say it. Say, oh, Johnny, this is good fun. Oh, Juanito, this is muy alegre. ¿Verdad? Gee, I don't know what any of that means, but okay. Oh, híjole, Juanito. This is no bueno. Okay, what if we have this? Get this if you're so smart. Square root of -75 divided by the square root of -3. Now, I'll tell you, when you get to these problems on the test, especially if it's kind of about in the middle of the test and your brain goes numb, just ask yourself, what can I do? Here we can take the I out of here. Remember, the negative under the radical, we can just pull out an I, square root 75, divided by, same thing here, I square root 3. And remember, any number divided by itself is 1. Right? I divided by I is 1. So we can just eliminate that. So what do we end up with? Square root 75 divided by square root 3. Now we can put these under the same radical. Remember we did this last time. Square root 75 over 3, which is the square root of 25, which is 5. Okay, remember you can treat I like a number. When you have an I divided by an I is just 1. Okay. Now, get this one if you're so good. Square root of -32 divided by the square root of 8. Okay, let's get rid of this negative in here. We get I times the square root of 32 divided by square root of 8. Now let's write this under one radical. So we have I square root 32, oh, stupid boy, over 8. So this is I times the square root of, what is that, 4? I knew that. And the square root of 4 is 2. And don't forget the I out there. Mm-hmm. Mm-hmm. Before I forget, I'm not going to be able to send this recording to you probably until tomorrow morning because I ran out of room on the cloud. So I'm having to record this onto my computer. And I don't live where this computer is. So, well, I don't know. Maybe I can do it. I'll try. It doesn't have to generate and all that stuff. Mm-hmm. 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 Okay. Now what if we have this? 2 plus 8i plus 5 plus 4i. Now remember, the I is kind of like a number, and we can treat it like it's a number. Okay, so do we have any like terms here? Yeah, the 2 and the 5, 8i and 4i. 5 and 2, was that 7? Plus 12i. Is there anything else we can do here? This is not square root. It's none of that misery. We're just combining like terms there. Right, right. Okay. And am I going too fast? Miss Oyoa?
No,
No. Miss Mabry?
no.
No. Miss Richard?
No.
You okay? Okay. 4i times 2 plus 3i. Now remember, I is like a number, just like any other. However, it has some kind of special characteristics. So we're going to take the 4i, do distributive property here. 4i times 2 is 8i, right? And 4i times 3i, don't forget the plus in here, is 12i squared, right? Because I times I squared. Now, remember, we know what the value of I squared is. It's -1, right? So we have 8i this is -1. -1 times 12 is a -12. Can we combine these two things? No. And that's all there is to it. Isn't this fun? This good stuff here, huh? Oh, Juanito, you're such a dumb boy. Okay. What about this? Let me look at the final and show y'all what we have in store for you with these imaginary number things.
Number 17.
17? Oh, good, thank you. Yeah, you're right. Okay, -224. Is that the, oh, and 18 has an I in it also. And that's all. Is that all of them? I think so.
Yes.
Okay. You're not supposed to be looking over this early. Secret stuff here. Okay. I'm so stupid, I've already forgotten. Well, let's do this. Let's do one of these. This is not going to be on the file, but it's kind of a good manipulation of the i's and all that misery. 3 plus 5i times 4 minus 2i. Okay, distributed property, 3 times 4 is 12, minus 6i. Okay, 3 times negative 2 is negative 6i. Now we do the same thing with the 5i. 5i times 4 is a plus 20i. Is that right? My brain just slipped out of gear there. Yeah. Minus 10. Now remember, you've got I times I, so that's going to be I squared. And remember, we know what the value of I squared is negative 1. Okay, let's combine like terms. 12 plus 14i. Is that right? Negative 6i and 20i. I think it's 14. And we have negative 10 times negative 1. Right? I squared is negative 1. So we have 12 plus 14i plus 10. Negative 10 times negative 1. So this is going to equal 14i plus 22. Okay? These problems are not difficult at all, I promise. They're just different with all this I misery. Okay. Does anybody want another one of these? Nobody? Okay. Now, this is about as difficult as these problems get, and you will see one of these if it's like it was last year. 8 plus 9i divided by 5 plus 2i. Now, there's only one. What the hell's texting me? Yeah, who cares? Okay. Now, how are we going to get rid of this I in the denominator? If we multiplied by 5 plus 2i times 5 plus 2i, we're going to get 4i squared plus 20i. That's not going to help us. How we get rid of the I in the denominator? We're going to multiply by the conjugate. Remember, the conjugate of this is going to be 5 minus 2i. 5 minus 2i. Now look, I'm going to go ahead and do the distributive property out here so you can see that how we're going to get rid of this. 5 times 5 is 25. 5 times negative 2i is negative 10i. Is that right? Yeah. Now we do 2i times 5 is plus 10i. You can see these two are going to eliminate each other. That's what a conjugate does. And 2i times negative 2i is a negative 4i squared. Now we're going to do the same thing up here. 8 times 5 is 40. Minus 16i. Is that right? And then 9i times 5 is a plus 40. Oh, will you stop? Minus 18i squared. Can y'all read that? I wrote it so small. Who is texting me? Stop all this texting. Oh, I think they texted me by mistake. It's the only text I ever get are mistakes. Okay. So this is going to equal 40. Now we have negative 16i and positive 45i is going to be a positive, is that 29? I think that's right. 29i. These two here are like terms. Minus, now remember, I squared is negative 1, minus 18 times negative 1, all over 25 minus 4 times negative 1. Okay, I squared, negative 1. Okay, let's clean this misery up here. Negative 1 times negative 18 is a positive 18. So we have 40 plus 18 is 58. 29i plus 58 over 25 minus 4 times negative 4 times negative 1 is a positive 4. So it's going to be 29. Okay, 25. Right? Right. What are these people doing? Goodness. Now remember, when you have two separate terms here, you have to be able to divide by something in the denominator that will go into these two evenly, both of them, not just one. So this equals 29 divided by 29 is 1i or just I, and 58 divided by 29 is 2. Now remember, the answer here could be I plus 2 or 2 plus I. Same thing, just like 3 plus 2 or 2 plus 3, the same thing. Okay, the secret to doing this, again, when you've got an I in the denominator, is to multiply by the conjugate. Probably should have done this one first. What if we have this? 1 plus I divided by I. Now, can we divide each one of these things by I? No. Remember, you'd have to have an I in this term here also. So what can we multiply by to get rid of this I in the denominator? Because remember, we can't have, it's an irrational number and there's none real number. And you can't have that in the denominator. So what we're going to do is, we're going to multiply by negative I. Okay, now we're going to distribute the negative I in the numerator times everything in here. So we're going to get negative I. Negative I times 1 is negative I. Minus I squared. I times negative I squared. Over negative I squared. Okay? Excuse me. So let me go through this a little bit. Negative I minus 1. Remember, I squared is negative 1. Over, this minus is outside. Minus a minus 1. Okay, I squared, negative 1. So now we have negative I plus 1 over 1. which is 1 plus, stupid boy, is 1 minus I over 1, or just 1 minus I. Okay? Let's see, what else do we have? I don't think we need to do that. Who was it that has looked through the final? Which one of y'all? Ms. Richard, was
Me.
it?
Yes.
Did you see any completing the square in there?
No.
Okay, I don't remember it either. We'll just kind of forgo that until, if we get enough time, sometime we'll do it. Thank you. Mhm. Okay, so what if we have this? Is the last one, unless you want more. 23 minus I divided by 3 minus I. Now remember, we can't have an I in the denominator. Excuse me. So what are we going to do? Multiply by the conjugate. That'll get rid of the I. So we're going to multiply by 3 plus I. Okay? Now we do distributive property. 3 times 23 is 69, I think. Minus 3I, right? 3 times 23 and 3 times negative I. Okay, now we do the same thing with the I. Or we can do the same thing with this, the negative I here. That's going to give us negative, wait a minute, did I do that right? Yeah, negative 3I minus I squared over Wait a minute, that's not right. Stupid boy. I'm so stupid. That's not right. Yeah. Let me go back. 23 times 3 is, I'm sorry, 69 plus 23 times I is plus 23I. Okay? I'm sorry, I was going back and forth here. Now, a negative I times all this misery here is negative 3I minus I squared over. Now remember, when you have a conjugate like this, all you have to do is multiply the first numbers and the last. 3 times 3 is 9. Negative I times I is a negative I squared. Okay, let's combine like terms here and get rid of this negative I squared. So we get 69 plus 20I. Okay, remember, I squared is negative 1. Minus a minus 1 makes it a plus 1. All over, and again, this is negative 1. So it's 9 plus 1. Minus a minus is a plus. Right. Then we have like, oh, please leave me alone. Why are these people doing this? Oh, she's thanking me for her birthday prize. Okay. 69 plus 1 is 70 plus 20I divided by 10. Everybody okay with this? Okay. Now again, we have two terms up here, and they both have to be divisible by 10. If they're not, this is the answer. But they are divisible by 10. This is 7 plus 2I. right? Right. Well, we've got time to do some completing this square. Is everybody okay with this eye misery? Everybody okay? Anybody want another one? I'll be glad to do it. Okay. Okay, completing the square. P-L-E-T-I-N-G. The Okay, if we had x plus 5 all squared, this would equal x squared plus 10x plus 25. Okay? This is a perfect square. It's this. Now, if you'll look, if you take half of the linear term, so half of 10 is 5, and 5 squared is 25. So half of this squared will give you that. Now remember, when we solved equations before, quadratics, we always set it equal to 0. Well, this one, we don't do that. Okay, if we have this, if we have a squared plus 6a plus 7 equals 0. Okay, when you're completing the square, move the constant to the other side. So you get a squared plus 6a. Now we subtract 7 from each side. We're going to leave a little space here to complete the square. Equals a negative 7. Oh, this one's stupid. Well, okay. Now we take half of the linear term. Half of 6 is 3. 3 squared is 9. Now this is an equation. Whatever you do to one side, you have to do to the other side. Now this is a perfect square. We just made it one. This is a plus 3 all squared equals 2. Right? Right. So how do we do this? Square root, square root. So we get a plus 3 equals the square root of 2. Now we subtract 3 from each side. Okay, square root of 2 minus 3, these are not like terms. So you're going to have the square root of 2 minus 3. I'm sorry, that one came out nasty and dirty. Yeah, this one will come out right, I think. Again, it's called completing the square. So if you have this, if you have b squared plus 6b minus 40 equals 0. Remember, when you're completing the square, you don't set it to 0. You move the constant to the other side. So we're going to add 40, and we get b squared plus 6b. I'm going to leave a little space here to complete the square, equals 40. Half of 6 is 3. 3 squared is 9. So we add 9 to each side. Now b squared plus 6b plus 9 is b plus 3 all squared equals 49. After you do a few of these, you'll prefer to do this rather than something else. These are real simple. Okay, now how do we undo a square? square root, square root. So we have b plus 3, excuse me, equals plus or minus 7. Right? So we have two possibilities here. B plus 3 equals 7 and b plus 3 equals negative 7. Subtract 3 from each side. B is 4. And this one, subtract 3, and b is negative 10. Okay, again, what we do here is we move the constant to the other side. Take half of the linear term, square it, and when you add it to one side, you have to add it to the other side. Anybody want another one of these? No? Where is everybody? We got 3 people here, 3 out of 12. Okay. That's the end of the book. Again, Wednesday, we shall begin review for the final exam. Okay. I'm turning the recorder off.